Variation. First we have direct variation. This is a new kind of language when we say y varies directly as x. What this means is that y and x satisfy this kind of relationship here, that y is equal to k, which we call the constant of proportionality, or the variation constant, that y is equal to k times x. We could also use the word y is directly proportional to x, and that means the same thing. If we just examine this for a moment and compare it to y equals mx plus b, so we have our y equals kx and our y equals mx plus b, we can observe a few things about this kind of direct variation. The y's line up, the x's line up, and it looks like k is in the place of m. This tells us that that constant of proportionality is the same as the slope, right? In this case. And our b lines up with no term at all, which is like lining up with a plus 0. So this also tells us that b is equal to 0, which means that the line passes through the origin, 0, 0. So what it means for y to vary directly as x is that they have a linear relationship and that the line passes through the origin. So there are lots of different things that satisfy this kind of relationship. A fairly common example would be unit conversion. If you're converting distance from miles to feet, you would multiply the number of miles by 5,280, because that's the number of feet in a mile. So in that example, your constant of proportionality would be 5,280. And we know that it would pass through the origin because 0 miles is 0 feet. So this is the kind of thing that satisfies a direct variation relationship. Briefly, let's leave this table behind and come down to these questions, where in the first one we're asked to find the constant of proportionality, given that y varies directly as x. The first thing we do with this statement is we convert it to an equation. We want to get it algebraic so that we can plug into it. Then we look at the two numbers that were given, y equals 12 when x equals 8. So this tells us that we want to plug in 12 for y. This is giving us one ordered pair, and plug in 8 for x. And we're asked to find the constant of proportionality, so what we're going to do is plug these numbers in and then solve for k. Very simple problem, right? 12 equals k times 8. Divide both sides by 8 to get k equals 3/2. So most of these problems are not very hard as long as we understand what to do with the language. If we understand what to do with the statement y varies directly as x, then the rest of the problem we can just kind of feel our way through. Coming back up to this table at the top here, we've got direct variation, which is a linear relationship, and then we can also throw in some modifiers on that x variable, like y varies directly as, instead of just x here, we have the square of x. Whatever this expression is, we should be able to translate it into something algebraic. So in place of the x, we now have an x squared, or y is directly proportional to not just x, but the square of x. Both of these are equivalent statements. So we could have anything in there, the cube of x, the square root of x. It could be anything that we can translate into an algebraic expression. These are not linear. Of course, this is more like a parabola if we were to draw its graph. So some of these other observations that we made about k being the slope no longer apply if that's not just an x. Inverse variation, as soon as we see the word inversely instead of directly, that tells us that we want to divide. K always comes first, so y equals kx for direct variation, y equals k over x for inverse variation. We divide by the variable, we never divide by k. Similarly, we could say y is inversely proportional to x. That has the same meaning. So coming down to this next question below, we're told that y varies inversely as x. This tells us that the relationship y equals k over x is satisfied. And then we're asked to find the variation constant, or the constant of proportionality, when y equals 8 and x equals 2. So plugging those in, 8 for y, 2 for x, gives us 8 equals k over 2. And we multiply both sides by 2 to solve for k, which gives us k equals 16. Be sure to actually set up the equation and solve it with these. It's fairly common for people to look at these numbers and just think that k is 4 because 8 is a multiple of 2, and maybe if we don't go through the steps carefully, it just looks right. But no, we can see that we in fact have to multiply both sides by 2. We don't end up dividing both sides by 2 in order to solve this equation. Next we have the question, find the constant of proportionality and write the function relating the two variables. So first of all, we're going to look at this statement here, and we still translate it into an equation. Y varies directly as the cube of x, that's multiplying because it's directly. So y is equal to k times the cube of x, which is going to be x cubed. Then we're given y equals 54 when x equals 3. So again, we're given an ordered pair, and we can plug these values in for x and y. 54, 3. Note that only the x gets cubed, the k does not. So this becomes 54 equals k times 3 cubed. And 3 cubed is equal to 27. So let's rewrite this as k times 27, and then we divide both sides by 27 to get that in fact k is equal to 2. This time we're not done at this stage. We're asked also to write the function relating the two variables. That means we're going to go back into this y equals kx cubed, and we're going to plug in k. I'm just going to plug in this value 2 that I found for k. I have to leave x and y as variables here. Knowing what to plug in and what to leave as variables is the main source of confusion on these problems. K is a constant. While two different examples of direct variation may have different constants, for this one particular example there are lots of ordered pairs x, y that satisfy it, but there's only one k. So the function relating the two variables is only going to substitute in for k, and it's going to leave x and y as variables. We're saying that this equation y equals 2x cubed describes the relationship between x and y. And I know it says function, and I'm leaving this in equation language because we're talking about the variables x and y. It would be okay to convert this to function language and call that y of x. This would also be fine. But generally when we're talking about x and y, we tend to leave them just as simple variables.